Going to start the first chapter of class 9, rest and motion. Alright, rest and motion. Everyone we are acquainted with the motion and rest, but we use in the general sense. Today we are going to study what is rest. Generally we think that we are sleeping on the bed, we are in the rest. We are watching the TV, we are in the rest, but it is not true. If the position of an object, suppose the board, this whiteboard is lying on the wall, its position does not change with respect to the surrounding, then the board is at rest. Alright, so I am going to write here, if the position of an object does not change with respect to the surroundings, then the body is said to be at rest. Example, we can take anything we can take example. Suppose the board on the board line on the wall or things like that, etc. So you can write in the answer. So, whether this board is at rest or motion, today I am saying it is lying on the wall. Tomorrow if we come, still it is lying. So the time is passing, but the position of the board does not change. So we can say that the board is at rest. See the fan, the fan has been fixed on the wall. If we do not start the fan, if it is at rest, we can say the position of fan with respect to wall does not change. So we can say that the fan is at rest. Now we move to the motion. These are a very simple common thing. We did day-to-day use it. Alright. Motion. Just if the position of an object changes with respect to the surroundings, then the body is said to be at in motion. Suppose if we walk, we are cycling, all these are the examples of the motion. If you start for a school, you leave your home at 6:30 a.m. You reach school at 7:30 or 7. So the timing is changing and your position is also changing. Earlier you were at your home, now you are in the school. So the timing is also changing, the position is also changing. So we can say that you are in the motion. The same way the train, when the train is running, it left the railway station, reaches somewhere at a particular time or at any certain time, so the train is also motion. So these are the examples of the motion. So we can write anything, example. So moving train, blowing air, all these are examples, you can write anything. So these are the things. So rest and motion. So rest, the position of object does not change with respect to the surrounding, and the motion, the position of object changes with respect to the surrounding. Alright. But see, when we see the definition of rest and motion, sometimes we get confused whether the body is actually at rest, whether the body is actually in motion. So the next topic is that rest and motion is a relative term. A relative term. Relative. What is the meaning of relative? We use the word relative. He is my relative. You are my relative. What is the meaning of relative? Look, what is the relation between me and you? I am teacher and you are my student. Because I have more knowledge than you, that's why I am teaching you. So I am a teacher here. When you go to your home, you are no more students. You are son. Because your father has given birth to you. The same way, your relation, your position, your name changes according to the relations. So relation is what? Comparative term. So rest and motion is a comparative term. Really, when we compare, its definition changes. Look, suppose, how it is a relative term. Suppose you are sitting in a train. Suppose you are sitting in a train, a running train. So there may be confusion whether we are at rest or whether we are in motion. Look, see it carefully. You are both in the rest and motion, because when you are sitting in the moving train, you are at rest in comparison to the object lying inside the train, because its position does not change. The train has moved from Muzaffarpur to Samastipur or somewhere. The seat, the fan which is fixed in the train compartment does not change. But when you see outside the train, you see that the position has changed. Now it is no more Muzaffarpur, it is a Samastipur. So timing is also changed. So both you are in the rest as well as in motion. So whether you are in the rest or motion, it depends upon the comparison. So I am writing in a brief. You will write ahead. A person sitting in a moving train. A person sitting in a moving train is at rest. In comparison to the object lying inside the train. But at the same time, he or she is in motion. Comparison to the object lying outside the train. Alright, a person sitting in a moving train is at rest in comparison to the object lying inside the train, but at the same time he or she is in motion in comparison to the object lying outside the train. Video को pause करके इसको कर लेना. Alright, move to the next one. Okay. Alright, so rest and motion is a relative term. So whether it is a motion or whether it is an rest, that depends upon the relation to the object. The next is reference point. A reference point. Reference point. What is the meaning of reference? Once again we are using the common word. Physics is that science, you know, that is used in day-to-day our life. So every word is known to us. Alright. What is the meaning of reference? अरे भाई हम लोग generally use करते हैं, we generally use. इसका reference में बहुत अलग है. If you go to the hospital and the doctors refers to somewhere. Alright. That is the difference. Suppose you are lying somewhere. Suppose you are lying in Saraiyaganj somewhere. So how can you give your address? You will say that go to the Saraiyaganj tower. From the tower, move to the left or right, whatever it is, and then after 2 meter, 2 kilometer, whatever 200 meter, our home is there. So this is the general way of talking. कि भैया सरैयागंज चला जाना, सरैयागंज से बाएं मुड़ जाना. So there are two things, the Saraiyaganj and by left. So what is the reference point? जब भी कोई तुमसे पूछे, whenever someone asks you where do you live, you always you say like this, from the Saraiyaganj or somewhere. So Saraiyaganj is a fixed point. And with respect to the fixed point, with respect to the tower, you say that move to the left, move to the right. What is the left and right? It is direction. And say 200 meter, that is a distance. So, reference point, what we can define, it is the fixed point. It is the fixed point with respect to, in short we write like this, WRT, with respect to. It is a fixed point with respect to which, it is a fixed point with respect to which the position or direction of an object is determined. Alright? It is a fixed point with respect to which the position or direction of an object is determined. अच्छा चलो भाई सही है, things like that we talk about like this to give you the conceptions. But when we talk about mathematically, how can we represent the reference point? This is important. How can we represent? Alright, we take the help of mathematics. Let us see here. You know the number line? This is what? This is origin. And from the origin, which is T, from the origin, suppose here it is 1, it is kilometer, meter, whatever it is, 1 kilometer, 2 kilometer, 3 kilometer, it is kilometer, 4 kilometer. And what is this? -1, -2, -3. Alright? This is also in kilometer. It is all like, it is well acquainted to all of you. The number line. Alright. Suppose this is what? This O is what? Origin. In mathematics we have studied this is the origin. So this origin is considered as fixed point. Reference point. Reference point. Suppose we move to 2 kilometers. Then what does it mean? Suppose we move plus 2 kilometer or minus 2 kilometer plus 2 kilometer. What does it mean? It means the body is at or in the right direction, because plus represents the direction and minus is just opposite the plus, and you know what do we do in the number line? Plus 2 kilometer means what? It represents that the body is at 2 kilometer distance to the right side to the fixed point. So, if we write 2 kilometer plus 2 kilometer, it means the body is at 2 kilometer to the right from fixed point, from reference point. So these are the 3 things. The body is at 2 kilometer to the right from the reference point. So what do we information from the reference point? 2 things: the fixed point and the distance from the fixed point. Alright, this is the reference point. You take help in the mathematics also. Alright, now the reference point is over. Now we move to the physical quantity. This is very important. What is the meaning of it is not O, this is physical quantity. Please worry, is all it. Physical quantity. What is the meaning of physical quantity? Do you know anyone? The physical quantity is that the quantity which can be measured directly or indirectly. The physical quantity is one which can be measured directly or indirectly. Alright? But the quantity cannot be measured, is not a part of physics. Alright? we study those quantities which can be measured. Suppose honesty, we cannot measure the honesty. Love, hatred, all these quantities cannot be measured. So this is not the part of the physical quantity. Alright? So physical quantity is one which can be measured. Yeah, physical quantity are those which can be measured directly or indirectly. Alright. So we can divide physical quantity in two ways generally. It is a scalar quantity. A scalar quantity. And second is vector quantity. Vector quantity. Third is also tensor, but it's not a part of even it is taught in the BSc. So we are focusing on two quantity, a scalar quantity and vector quantity. What does it mean? Alright. What is the scalar? Scalar quantity let us see a scalar quantity. Alright. Which quantity can be called as a scalar quantity? Those quantities which have only magnitude, only magnitude, no direction, and can be added algebraically. You know, there are three ways we can add the quantity: arithmetic, algebraically, and vector. So, in class 9, generally teacher teach it has only magnitude, no directions. So, those quantities which have magnitude only and can be added. Can be added algebraically. So, magnitude only. When there is a quantity, definitely it should be added. So, algebraically, not vectorally. So, what may be the example? Mass. We can take the mass. Or mass, density, mass, density, volume, could be volume. So, these are the scalar quantity. More, something more also. Distance. These are the common thing. Distance, not displacement. Vector quantity is what? It has both magnitude as well as direction, and it is the way of addition. It is vectorial. So class 9th we only simply teach those quantities which have a magnitude relations. It is not the separation process. So those physical quantities which have both magnitude and direction. And what is the method of addition? Magnitude base and can be added by the rules of vector. Added by the rules of vectors. अरे rules of vector नहीं होता है. Triangle law of vector addition, triangle law of vector addition, triangle law of vector of additions. All those things. Or polygonal or vector additions. So example maybe we can write here displacement accelerations force also. So these are the examples of vector quantity, but here is important, can be added by the rules of vector. How can we add? Is there any certain quantity or any quantity which are both magnitude and directions, but they are not vector quantity? Suppose electric current.